Hello, hi everyone. This is Tushar from Biotechnica. I welcome you all to this session of General Aptitude. So I'm again back with a very interesting and important topic for CSIR Net Aptitude, that is calendar problem. Good evening, Sanchari. Can you just confirm that my audio is clear? Good evening, Tej. So share this link with your friends so that they can also learn this beautiful concept very easily and solve some questions in the CSIR Net Part A. Great, Subra. Good evening. Okay, fine. So the problems and questions related to calendar are very tricky, but once you know the concept behind it, they are very simple and you can solve them easily. And after this session, I'm sure that you'll be having a clarity of how to deal with these questions. So just we'll wait for a couple of seconds more and then we can begin with today's session. You can also join the Telegram group of Biotechnica that will help you to get notification and other contents that will help you in pursuing your future, pursuing in your career for clearing CSIR Net. So we'll just wait for 1 more minute and then we can begin the session. Okay, then let's start with this session today. So before we dive into the different questions that we'll be seeing in calendar problem, let's discuss some of the fundamentals on which we'll be building today's session. So just I'll refresh your memory regarding some of the fundamental concepts that we'll be using in calendar problem. The first is, I'm sure you all might be knowing this, that in a particular year, we have 365 days. Now, for those years which have 365 days, we call it an ordinary year. That's the nomenclature we are giving it. So an ordinary year is a year which is having 365 days. So if you just divide 365 by 7, that is days per week, you will be getting 52 weeks plus 1 day extra. So this is what is important. And maybe in a couple of slides, we'll be seeing this importance of 1 extra day that we are having. So in a particular year, which we are calling an ordinary year, which contains 365 days, it has 52 weeks and 1 day extra. Now moving to the next thing, that is 1 leap year. So we all know that in leap year, in normal year, we have February 28 days. But in a leap year, for February, we will be having 29 days. So this 29 days will make the number of total days in a year to be 366. So if you just divide it and see it in terms of weeks, we'll be getting 52 weeks plus 2 days extra. So these are the two fundamental things that we'll be very readily using in this topic. Now, the next concept is how to check that whether the given year is a leap year or not. How do we do it? So there are 2 points to check it. First, if it is a centurion year. Now, what do we mean by centurion year? Suppose we are having something like 1200, 1600, 2000. So these are basically centurion years. Why? We can see double zeros behind it. So century means 100. So centurion years will be having double zeros at the end terms. So how do we check that these years are leap year or not? For this, you have to divide them by 400. So the most important thing how to check for leap year is the first thing that you need to divide for the centurion years by 400, and any other year other than this centurion years where they are having last two digits at zeros, other than that, if you are having any year, you can just divide it by 4, and if it is completely divisible by 4, that will be a leap year. For example, let's say 1996. If you take 1996 and divide it by 4, it will be completely divisible. So this is a leap year. So these are the 2 criteria that we'll be keeping in mind when we are checking the leap year. Now, coming to the next important topic, that is counting number of odd days. Yes, we can do so. Counting number of odd days. Now, how do we count this number of odd days? Is why it is important. First, let's try and understand why this number of odd days is important. So whenever, let's say, I'm saying that January 1st let's say I'm saying it's a Sunday. Let's say I'm saying it's a Sunday. So after every seventh day, after every 7th day, again the first day will come. So if we add 7 to the first one, 8 Jan, in 8 Jan we'll be getting again a Sunday. Similarly, we will just keep on adding 7 to this, we'll be getting the same day. So 8, 15, 22, 29. So this all will be getting a Sunday. Now, in this particular month of January, if in the particular month of January, it has 31 days. It has 31 days. So if you see, if you divide 31 by 7, we are having 4 weeks plus 2 days extra. Now, this 2 days extra for this 4 weeks, whatever we are having, the same, if we take a starting day to be Sunday, then we will be getting similar days with this. But the 2 extra days, we just need to add one day. For example, we have seen that 29 January, we have seen that considering that 1st Jan is a Sunday, we can just keep on adding 7 and get the same respective dates for the Sunday in the month of January. So the last date we are getting 29 Jan to be Sunday. So the 30th and the 31st, these are the 2 odd dates. I'll just write it over here. 30th and the 31st, these are the 2 odd dates that we are seeing in the month of Jan. 29th, so these are the odd dates that we are seeing in the month of Jan. So these 2 odd dates will be helping us to see how this we can add and get the different dates. For example, if 29 Jan is Sunday, then the 30th will be Monday and 21st will be Tuesday. So basically using this 7 number and getting the odd number will help us to correlate with the different dates. Okay, correlates with the different dates. Correct. So correct Subra. Just you see, because we are adding the 1st Jan also here, you can see if you are adding from the 1st Jan, so that will be basically, if you are adding from the 1st Jan, if you are adding it, the last 2 days we are already consider the 31st one. Do you get the point? So that is basically taking care of the 29 days over there. If you start calculating, you're correct. If you start calculating, I'm just giving an example of what do we mean by 2 days extra. Okay, we will come to that point in greater detail when we will be talking about this. Okay, so I'm just giving you a point that if you are having 2 days extra, we can correlate this. Okay, so again, so in a particular year we are having 52 weeks. In a particular year we are having 52 weeks and 1 odd day extra. Now what this means, suppose we are having, maybe we'll take one question and try to understand this. Okay, we'll take one question and try to understand this. Similarly, in one leap year we are having 366 days. So we have discussed now that for 360 days we'll be having 52 weeks and 2 odd days extra. That means this last 2 days needs to be added up. We'll see with this example. Okay, now let's say if the question is asked, what are the number of odd days in 0 to 100 years? I'm saying, what are the number of odd days in 0 to 100 years? What are the number of odd days in 0 to 100 years? Let's say our calendar is starting from 0 and we are seeing till 100th year. So what are the number of odd days in 0 to 100 year? So I'll just clarify this and explain this. So whenever we are counting the number of odd days, for a period of year that is given to us, we'll see in this particular segment how many leap years are there and how many ordinary years are there. That is the first step. So the first step what we want to do is we want to see how many leap years are there and how many ordinary years are there. Now between 0 to 100, if you see, just divide 100 by 4, you will be getting 25. But the important thing is the 100th year. Now this 100th year is not a leap year. Why? We have already discussed that for a centurion year to be a leap year, it needs to be divisible by 400. So 100 upon 400 is not divisible by 4 completely. So between 0 to 100, we are having 24 leaps here. Between 0 to 100, we are having 24 leap years. And if you just subtract 24 from 100, that will be 76. So what we are seeing basically, so if I'm asking you the number of odd days in 0 to 100 years, so first task is to First step is to find the number of leap years and original years. So the number of leap years is 24. Why? Because the 100th year is the not a leap year. We have seen this, not divisible by 4. Similarly, just from 100, if you subtract 24, then there are 76. So there are basically 76 ordinary year. Now I'll just remind you of the fact that in a particular leap year, we were seeing 2 odd days extra. We have seen this. In a leap year, we are having 366 days. Basically, it will be 252 weeks plus 2 days. 52 weeks plus 2 days. So for a particular leap year, we'll be having 2 odd days. So just multiply with this 24 into 2. You'll get the number of odd days over here. And for the 76, you need to keep this. So what we'll be getting? We'll be getting 76 plus 48. Add this up. 8, 6, 14, 12. So the number that you are getting is 124. Now, what is the next task you have to do? You have to divide this number by 7 and see what you are getting. So 7 ones are 7, 54, 7 sevens are 49. So basically we are getting 5. So if we divide 124 upon 7, so we are getting a remainder of 5. So basically in 0 to 100 years, the number of odd days are 5. Number of odd days are 5. Is this clear for everyone? The number of odd days are 5. Great. Great, Subra. Great. The number of odd days are 5. Okay, Bhavya? Okay, you are asking, okay, why, how 25? See, Bhavya, whenever we are discussing between 0 to 100, you have to understand when we are considering 0 to 100, our first task is to see how many leap years are there and how many original years are there. So in leap years, if we see the number of leap years, then what you have to do? You just have to divide the number by 4. That many leap years are there. So in 0 to 100, if you divide it by 4, you are getting 25. But do you realize that this 100th year is not a leap year? Why? Because it is not divisible by 400. That's what we have seen. For a centurion year, it has to be divisible by 400. So that is why instead of 25, we'll be having 24. Is this clear for you? 24. So that's how we find out. So for 0 to 100 years, it's 5 odd days. So I'll just refresh it here. So for 0 to 100 years, it's just 5 odd days. 5 odd days are there. Now, similarly, if I ask you how many odd days are present in 0 to 1600 years. Now, similarly, if I ask you how many odd days are present in 0 to 1600. Now, why we are doing this? You will be seeing in questions, we'll be solving later questions where you have to find, given a particular date, on which day it is. So for these questions, you need to find the number of odd days. So that is the reason why we're discussing it properly. So the question I'm posing is the number of odd days in 0 to 1600 years. 0 to 1600 years. You can try this and find it out. 0 to 1600 years. So let's break this. Let's break this 1600 in a chunk of 400. So first let's 0 to 400. First try and understand 0 to 400, and then we can just simply multiply and see. If you multiply it 4 times, we'll be getting 1600. So that is a comparative thing. So for first 0 to 400, let's try and understand. So just now we have seen for first 0 to 100, the number of odd days is 5. That's what we have seen. Number of odd days is 5. Similarly, for the next 100 years, 100 to 200, it will be 5 again. Since per 100 years is 5. So from 200 to 300, it will be 5. 300 to 400, it will be 5. So basically, we are getting 20. Basically, we are getting 20 odd days plus 1. Now, why plus 1? Now, you can see this 400th year. You can see this 400th year. You can see this 400th year. This 400th year is a leap year. Why? The same reason that if we divide it by 400, it is completely divisible. So we are getting plus 1 over here. So from 0 to 400, the total number of days we are getting, odd days we are getting to be 21. Now, whenever you are getting any number greater than 7, just divide by 7 and see. So if we divide 21 by 7, You just get remainder 0. You get remainder 0. So the number of odd days is 0. Now the actual meaning you are getting for odd days, it means the number of days that we are getting extra. Now if we are having 21 days as extra, this 21 days can become just easily 3 weeks. Do you get the point? Whenever number of 8 odd days means the number of days we are getting extra. That many days we need to add or subtract according to the question. That is the thing. Now, if we are having 21 odd days, so what this means? This 21 odd days correspond to 3 weeks. 3 weeks. So after the end, how many extra days? So basically, if we divide it by 7, so we'll be getting a remainder of 0. So the important fact that we need to understand is, so Anupam is asking, is this odd day the extra day? Yes, correct, Anupam. Yes. So the 400th year, it will be a leap year. Correct. You are absolutely correct. So that 29th day we are adding. So for 0 to 400, the number of odd days are 0. Now just we can multiply it with 4 times. So for 0 to 1600 years, the number of odd days are 0. Okay. Now let's move to the next thing. So we will be correlating each day with a number. So Sunday is taken to be 0, Monday is taken to be 1, Tuesday is taken to be 2, Wednesday 3, similarly Thursday 4, Friday 5, and Saturday 6. This is how we consider it. Okay. Great, Nomi. Yes, we will be getting 0 odd days. Okay. So with this, let's try and solve the questions using the concepts. Now, this is the first question that I'm posing. The first day of the year 2020 was a Wednesday. The first day of 2021 would be, try and solve this question along with me. The first day of the year 2020 is Wednesday. So let's say 1st Jan. Let's say 1st Jan 2020 is a Wednesday. So it is asking us basically the first day of 2021. So 1st Jan 2021 will be which day? Try and solving this using the same method of leap year and ordinary year. You can use that same concept. Just check the number of, is this first thing whatever you do, see how many years it is given. Just check whether it is a leap year or an ordinary year and accordingly find the number of odd days. Now, if you solve this question, you'll get an idea exactly what is odd days. Great, Sanchari. Great, Subra. Yes. Great. So let's try and understand this. So this is the question. It is given to us that the 1st Jan 2020 is Wednesday, and it is asking 1st Jan 2021 will be what? This is the question that it is posing. Now let's see that from January 2020, it's given 2020, right? So from January 2020, 1st January 2020 to 1st Jan 2021, it's a complete year. So the next thing that you have to identify is whether this is an ordinary year or a leap year. Since you can see it's 2020, so 2020 will be a leap year. So we know for a particular leap year, we are having 2 odd days we are having. Now, what this 2 odd days means? Let's try and understand. So 1st Jan is 2020 and it is given as Wednesday. Now, we need to see that for a particular year, it is 52 weeks. Now, if you see exactly, you count 29th December. Just I'll use this up. Wait. So the 1st Jan 2020 is Wednesday. So we need to find 1st Jan 2021. So the first thing you have to do is see the gap. So it is basically 1 year. Now what kind of year it is? It is a leap year. Correct, Anupam? Correct. So this is a leap year. So in this leap year, how many days we are having? So 2 odd days we are having. 2 odd days we are having extra. 2 odd days extra we are having. Now if you see that in this year 2 odd days are extra. So for 52 weeks, if you start for the 52 weeks, we'll be ending with the same Wednesday. We'll be ending with the same Wednesday. So for the 31st, so for the first Jan, you just need to add 2 days here. So since it is Wednesday, you just need to add 2 more days over here. Since till Wednesday to Wednesday 52 weeks will be done, now we are having 2 more days extra. So these 2 days will be Thursday and Friday. So the correct answer is Friday. So the correct answer is Friday, C. Correct. Now moving to the next question. What day of the week will it be 61 days from Friday? Try this question out. What day of the week will it be 61 days from a Friday? It's a simple question, just you need to see accordingly. Try and see with respect to 7. So we know that for each 7 days we get the same date. So what day of the week will it be 61 days from a Friday? Try this question. Now 61 days it is given to us. Now what is the thing that we know? Let's start with the first day. Now if the first day is Friday, we know after 7 days again. So if we add 7 to it, then again on the 8th day we will be getting a Friday. From 8th day we will be getting a Friday. So basically in an interval of 7 days, we'll be getting the same day back. Same day back. So what we can do, we can take the 61 and just divide it by 7. So in this way, we'll see in how much bracket of 7 it is coming. So if you divide 7, you will be getting 7 8s are 56. So 5. So 5 is the remainder. So if we divide 61, we'll be getting exactly 8 weeks. If we divide 61, we'll be getting exactly, just I'll get this, 8 weeks. So 8 weeks are 56 and 5 days extra. So for the 8 weeks starting from Friday, for the next 8 weeks we'll be getting the exact Friday on the 8th week end day. So these 5 days are extra to it. So you just need to add 5 days to it, or else you can think in a different way. Great Romy, Anupam, Sanchari, or else you can think in another way. So the next round week will be 63. So just reduce 2 days. So in the 9th week, exactly if we calculate from the first day till the 9th week, we'll get a Friday again. But we are having a sort of 2 days, 61, right? 9 weeks would have come in 63 days. So just the nearest. So 9 weeks, 63 days. So we are having a shortage of 2 days. So you can just subtract 2. Either you can add 5 in Friday. So Friday, Saturday, Sunday, and you will reach Wednesday equally. Or you can go the reverse way. Just you know that 9th week Wednesday will be Friday. So just subtract 2 from it. So it will be a Wednesday. Great Anupam, great. So it will be a Wednesday. Is this clear for everyone? It will be a Wednesday. Now moving to the next question. If the day after tomorrow is not Friday, then which of the following days cannot be the day before yesterday? So this is a simple question, but just the words are very much looking jumbled. Try this out. If the day after tomorrow is not a Friday, then which of the following day cannot be the day before yesterday? Try this question out. Day before yesterday. So there is an alternative way to do this. First, you can consider that the day to be Friday. In that way, it will be easier for you to solve. Consider that tomorrow is a Friday and then solve it. Okay, Sanchari is saying Monday. Other guys, try and solve this out. See, you all focus on this line. The day before yesterday. This is important. The day before yesterday. Just check your answers, everyone, again. The day before yesterday. See, if today is this, if today is this, then the next day is tomorrow. The day after this is, I'm writing day after tomorrow. Just one day before today is yesterday. One day before yesterday is day before yesterday. And it is asking day before yesterday. Day before yesterday. I'm representing it DDBY. Day before yesterday. Yes, Sanchari, Subra, Murthy, yes, Sunday. So that's how. So this is important. Day before yesterday. Now, as I have said, you consider tomorrow to be Friday. So the day after Friday, the day after tomorrow to be Friday. So day after tomorrow is Friday. If day after tomorrow is Friday, then what will be day before yesterday? So Friday, Thursday, Wednesday, Tuesday, Monday, Sunday. So if the day after tomorrow is Friday, if I'm just writing the short form, day after tomorrow is Friday, then day before yesterday will be Sunday. This is what we have got, Sunday. Now what is the question asking? If the day after tomorrow is not a Friday, it's not a Friday, then which of the following days cannot be the day before yesterday? So it will be Sunday. This is clear for everyone? Sunday. Okay, great Sanchari. So it is Sunday. So what was the take home message? Whenever you are getting this question, have some patience. So this is a simple question. Thus they are confusing with the words. Day before yesterday they have asked you. Okay. So just be careful when you are solving these questions. So it is Sunday. Moving to the next question. If a 4-digit year is chosen randomly, what is the probability that it is not a leap year? Try this question out. If a 4-digit year is chosen randomly, what is the probability that it is not a leap year? That it is not a leap year. This is a very interesting question. If a 4-digit year is chosen randomly, what is the probability that it is not a leap year? It is not a leap year. It is not a leap year. Okay. Murthy is saying 3/4. Sanchari is saying 3/4. Other guys, try and solve this out. Romy is saying option D, greater than 3/4. Okay, Subra is saying 3/4. Okay. So let's try and understand this. There is a very important concept that we need to understand. So let's start from a very basic example. Let's consider, although they have said to be first 4 digits, let's consider first 0 to 100. So what we have seen for first 0 to 100. This is the example that we have taken already, so it will be easier for you to understand. So let's consider in first 0 to 100 years, how many are the leap years and how many are the ordinary years. So if we have discussed this, for a leap year, number of leap years for 0 to 100, it is 24. And the number of ordinary years for 0 to 100, it is 76. Now, do you get this thing? So you can notice here that this is not exactly equal to, for when we're considering 0 to 100, it is not exactly 25. It is less than 20. It is less than 25. It is less than 25. So if we see the probability of choosing a leap year, I'm just writing 1/4, or maybe I'll just change this out. The probability of getting this less than leap year, getting a leap year is less than 1/4. That's what we have seen. Because if we consider 0 to 100, this 100th year is not a leap year. 100th year is not a leap year. Why? We have discussed it is not divisible by 4. That's the reason it's not a leap year. Do you get the point? It's not leap year. So whenever we are having this scenario, whenever we are taking this, so we are considering, so the number of leap year is less than 1/4. The number of ideally the number of leap years should be the duration that we are having divided by 4. That should be the case. But if we consider this, since 100th year is not a leap year, because why this is coming, we have 2 conditions to be satisfied for a leap year. It should be divisible by 4 And if it is a centurion year, it needs to be divisible by 400. That is the reason why the probability of finding a leap year, I'll just write this, the probability of a leap year, finding a leap year, is less than 1 by 4. Is this thing clear for everyone? Less than 1 by 4. It is less than 1 by 4. Okay. Now, if the probability of this probability of leap year is less than 1 by 4, so the probability of getting an ordinary year, that's what it is asking. What is the probability that it is not a leap year? So what is the not a leap year? It is an ordinary year. So the probability of getting ordinary year will be greater than 3 by 4. So the correct option is option D, greater than 3 by 4. So what is the important thing that we need to keep in mind? So whenever we are seeing a segment or a period, the number of leap years are not exactly the 1/4 of it. We know the reason why. We are having two conditions. That is why if it is violating basically the 100th year will be violating this. So we can just generalize this. So the number of leap years is just less than the 1/4 of the period that is mentioned to us. Okay, correct. So moving to the next question. What is the maximum sum of the number of Saturdays and Sundays in a leap year? Try and solve this out. What is the maximum number of Saturdays and Sundays in a leap year? What is the maximum number of Saturdays and Sundays in a leap year? This is a very important question. Try this out. And it is also important that they have already given that it is a leap year. So whenever just reading the question, try to think properly. Whenever it is saying to be leap year, you need to be very careful. Just in a hurry, you don't write and solve it using 365. That's what is important to state here. So whenever you are seeing a leap year, take a pause and think, and just use the proper value for it. Great, Shubhra. Shubhra is saying 106. Jhalak is saying option C, 106. Sanchari is saying 106. Great. So let's try and understand this. So what is the maximum number of Saturdays and Sundays in a leap year? So what we have seen in a particular leap year, we are having 366 days. So basically this 366 days is broken into 52 weeks. We have seen this 52 weeks plus 2 days extra, 2 days extra, 2 days extra. Now in this 52 weeks, we'll be having 52 Saturdays and 52 Sundays. 52 Saturdays and 52 Sundays, because we are having 52 weeks. So what is the maximum number of Saturdays and Sundays we can get? Because Saturdays and Sundays are conjugated, we can have a combination where the Saturday and Sunday will be coming. So eventually we'll be having for this 52 weeks, we'll be having 52 plus 52, 104 plus 2 days. Those 2 extra days can be used. Anupam, you need to consider that the maximum number of Saturdays, Sundays, the 2 days factor, the 2 odd days factor that we are having, that will basically decide the maximum number of Saturdays and Sundays that we can get. So that you need to keep in mind. So in a leap year, we are having this 2 odd days, and we can also have these days together, Saturdays and Sunday. We can easily have the Saturday, and since they are conjugative days, one after another. So after the 52th week, so if you try and find out if the first Jan you are taking it to be a Saturday, since we need the maximum number of days, you can start it with Saturday. So you can see that till you reach 29th December, you will be completing your 52 weeks. Considering this is a leap year, you'll be completing your 52 weeks. So this 30th and 31st, after, you can again have this. Okay, you can again have this. Okay, Venkatesh. Okay, Anupam, I'll explain you again. See this. First of all, let's start with 1st Jan. I'm just giving you an idea. Let's start with Saturday, since we want maximum Saturdays and Sundays. So if we add first 7 days to it, on the 8th, or maybe I'll just repeat this, on the 7th day, on the 7th Jan, So it will be a Saturday, first will be Saturday, then a Sunday, then a Sunday. So on the 8th Jan, so again we'll be having this Saturday. So this first week is completed. This first week is completed. So Anupam is, see Anupam. So whenever we are having 52 days, 52 weeks, if you are calculating 52 weeks, for this 52 weeks, we can have this 52 thing. We can have this 52 Saturdays and 52 Sundays. We can have this 52 Saturdays and 52 Sundays. Now the last thing, when we will be reaching 29th, when we will be reaching 29th December, you can try and relate this. When we are reaching 29th December, it will be a Friday. You can solve this out. You can try and solve this out. If we take the 1st Jan to be Saturday, and we solve it for 52nd week, the last day of the 52nd week will be a Friday. So the 29th December will be a Friday basically. So 30th and 31st December, we can have again Saturday and Sunday extra. You can try this out. You can solve this and try this out. If you're starting with the 1st Jan to be Saturday, so 29 December, if you see exactly 29 December, the 52 week will be ending with this Friday. Okay. So this 2 days will be extra. So we'll be getting 106. Now moving to the next question. What is the chance that a leap year selected at random will contain 53 Saturdays? Great, Anupam. So try this question. What is the chance that a leap year selected at random will contain 53 Saturdays? First, what is the 53 weeks we are having? 53 Saturdays. What is the chance that a leap year selected at random will contain 53 Saturdays? Subra, you can try it out. You can try with the dates and check it. But the concept remains the same. You can try it with the dates and check it. So coming to this question, what is the chance that a leap year selected at random will contain 53 Saturdays? Great. Anupam is saying option 2. Option A, 2 by 7, right? Okay. 2 by 7. Now again that thing, key in a particular leap year, we'll be having 52 weeks. The same concept. So in 52 weeks, we'll be having 52 Saturdays and 52 Sundays. 52 Saturdays and 52 Sundays. This will be having 52 Saturdays and 52 Sundays. Now we are having 2 days extra. Now this 2 days extra can be what all days? We can write all the possible combinations. It can be Saturday and Sunday, or it can be a Sunday and Monday, or it can be a Monday and Tuesday, or it can be a Tuesday and Wednesday, or it can be a Wednesday and Thursday, or it can be a Thursday and Friday, or it can be a Friday and Saturday. These are all possible combinations we can have. So basically, from this 52 weeks, for a particular leap year, we are having 52 weeks. From these 52 weeks, we will be having 52 Saturdays and 52 Sundays. Now it is asking, what is the chance that a leap year selected at random will consist of 53 Saturdays? So what is these 2 days extra that we are having can have this, since there are 2 consecutive days, we can have a combination of this. Either the 2 days can be Saturday, Sunday, or it can be a Sunday, Monday, similar the combinations. Okay, so basically we are having 7 combinations, 7 different combinations that can fit into these 2 days. There's a possibility that these 2 days can come. Now you can see what is the possibility of getting Saturdays. So we just need one more Saturday. So this Saturday and Sunday can be a combination, and this Friday and Saturday can be a combination. So out of these 7 combinations, we can have 2 combinations which can add up to give this 53 Saturdays. So basically it is 2 by 7. So that's how we are getting 2 by 7. So just the 2 days extra that we are having, we need to write and see the different combinations that we are having: Saturday, Sunday, Monday, Tuesday, that all. And we need one more Saturday extra. So we can see from this combination where we are getting Saturdays. So this is one Saturday and Sunday, we'll be having one Saturday, and from Friday and Saturday we can have. So these are the two combinations that can give us one extra Saturday. So out of 7 possible combination, this 2 combination will give. So basically, if you want to find the probability random, so it will be 2 by 7. Okay, 2 by 7. Great. So moving to the next question. Try this out. A certain day which is X days before 17th August is such that 50 days prior to that day, it was 4x days since 30 March of the same year. What is X? What is X? Try and solve this out. What is X? A certain day which is X days before 17th August is such that 50 days. So first draw a diagram and try to see what is the question asking you. What is the question that is asking you? Try this, Anupam. I'll explain it, but still you can try by yourself. No worries, I'll explain it. So just read the question phase by phase. A certain day which is X days before 17th August. So we are having a timeline. Let's understand this. So this is 17th August. This is 17th August. It is saying a certain day which is X days before 17th August. So this is X day. Let's say this is point A. So this is X days before this. Is such that 50 days prior to it. So 50 days prior to it means 50 days before it. So 50 days before A is this. Let's say this is 50 days before A. Let's say this is B. 50 days before A is B. Just go through the question accordingly. Is such that the 50 days prior to that day, to A, 50 days prior to this, it was 4x days since March 30. So if we are having a date here, March 30, so this, from this to this, it is 4x. Do you get the question now? So try this, draw a timeline and try to understand this. So it is saying, I'll again repeat the question. It is saying that we have a date here, 17th August. Now it is saying which is X days before 17th August. So let's consider a date which is A, which is X days before 17th August. Now, again in the next line it is saying is that it is 50 days prior to it. So the point B, the date B will be 50 days prior to it. Now again it is saying that there is a date which is 30th March. This date 30th March is 4x from the prior date. 4x from the prior date. So prior date is B. So 4x. So from the 30th March, to this point B, the date B, it is 4x. Try this question. Just you need to find the number of days in this period from 30th March to 17th August. You need to find the number of days here. You need to find the number of days here. So just you can add what we are having. It is asking since 30th. So 30th March you just leave. So in March, basically we will be having one more day. So now we want to see the number of days between 30th March to 17th August. So 30th March is the day from where we are seeing. So in March, we will be having one more day extra. So it is 1 March. Just let me write April, May, June, we need July, and in August we are having 17 days. In August we are having 17 days. So in March we will be having 30 days. In March 30 days. In May 31 days. In June 30 days. In July 31 days. Do you get this? So you just need to find the number of days in between it first. So in March, since we are calculating from 30th March, from the next day onwards, we need to see the time period. So first in March, only 1 day is left. Again, then April is there, May, June, July, and August 17. Now, if you add all this, all this, the total number of days will be 140. If you add all this, the total number of days to be 140. Great, Rumi, Sanchari. Option A they are saying. Okay, let's try and see. So you got this point. The total number of days will be 140. We need to add from 31st March. Since March 30th is given, we need to see. So the total time days is 140. So I'll just remove this thing. I'll just remove all this. So the number of days, so the total number of days we are having 140. Now this 140 will just correspond to this, the length that we have written here. So it will be 4x plus 50 plus x. This is the timeline that we have according to the question it is given to us. So just you can solve for the value of x. So 5x is equal to 90. Just we are taking 50 that side. So x is 90 upon 5, which is 18. X is 90 upon 5, which is 18. So the correct option is option A, 18. Great, Subra Murthy, 18. Okay, so the important thing is to calculate properly the time length. That is important. Calculate properly the time length that we are having. Okay, moving to the next question. Which of the following month in 2021 will have the same calendar as that in this September 2020? Try and solve this question. Which of the following months in 2021 will have the same calendar as that in 2020, September 2020? So same calendar means, it is important to understand, same calendar means it will have the same day and the same date, and also the number of days in the month should be equal. Great, Rumi. Okay, Bhavya, the last question. Okay, other guys, you can try and solve this question. Till then, I'll just revise this question again. So, Bhavya, you can look here. So, go according to the question, what it is asked. It is saying a certain day which is X days before 17th August. First, take a timeline, fix the 17th August. This is 17th August. Okay. Now it is saying X days before 17th August. So let's say that particular date is X, that particular date is A, and this is X days. Now again it is saying 50 days prior to this. So we'll be having another day B, which is 50 days prior to this. Prior means before it. Prior means before it. Okay. So 50 days. Now in the last line again it is saying we are having another date March 30. So this prior date, that the point B we are having, this date, this difference is 4x, it is saying. Okay. Now you got the point. This difference is 4x. So the next thing that you have to do is to add upon all the values. You'll be getting to be 140 and just solve for the x. 5x plus 50 equal to 140. You'll be getting 18. Okay. Now moving to this question again. Yep. So which of the following month in September in 2021 will have the same calendar, same days and date as that of September 2020? Try this. You can start with September 2020. You can start with September 2020. You can use the concept of odd days again. So in a particular month, if it is having 30 days, so in this 30 days we'll be having 4 weeks, 28 days plus 2 days, 2 odd days. So this 2 odd days will help us in deciding the other date that we are having, because on the 7th, on the particular weeks we'll be getting the same date. So these 2 odd days will help us to find the exact next day. So in a month of 30, there are 2 odd days. In a month of 31, since 31, so it's 4 weeks plus 3 days. So there will be 3 odd days. Odd days means 3 extra days, 3 odd days. And for a month of February, you know, if it is not a leap year, then we are having 28 days. So basically it will be exactly having 4 weeks. So it has no extra days. And if it is 29, if it is a leap year, then we'll be having 1 odd day extra. Okay, 1 odd day extra. Great, Anupam. Anupam is saying June. So this is the concept that you need to use. For a month of 30, there are 2 extra days. For a month of 31, there are 3 extra days. And if you are considering a leap year, if you are considering February, if it is a normal year or ordinary year, 28 days will be there. So there will be having 0 odd days or extra days. And if we are considering a leap year, in that February will be having 29. So 1 extra day will be here. Okay. Subra is saying June. Okay. So let's try and understand. This. So September, let's try and see from September. So from September, let's start from September 1st. For example, let's start from September 1st. So from September 1st to October 2020, it is 1 month. September 1st to October 2020, it's a 1 month. And in the month of September, how many days we have? In the month of September, how many days we have? So we are having, just you can check that September will be having September, October, November. So this is having having basically 30 days. So in the month of September we are having 30 days. So how many days extra will be having? 2 days extra will be having from September to October. Similarly, if we move from October to November, so I'll just rewrite this. So from September 2020 to October, we are having 2 days, 2 odd days. From October to November, so it's a 31 days. So it's 3 odd days. Okay. Similarly, from November to December, we are having 2 days, because November to December, from November 1st to December 1st, 30 days will be there. So 2 days. Now you can see, if we add this all extra odd days we are having, we will be having 7 days. So this 7 days can, what is the question it is asking? Which of the following months in 2021 will have the same calendar year? So for having the same calendar year, it should, the number of odd days that we are getting should be divisible by 7. That's the logic, because whenever it is divisible by 7, we can have a complete week. So the same exact date can match. That is the concept that we're looking at. Now in December, we are also getting 7. But the important thing to note here, this September is a 30 days month, but this December is 31st. So this won't match. All the days of this calendar, all the days of this match won't correlate with the September. So this is not the answer. So again, we need to you can end it from here. So from December to Jan, you'll be having again 3 days. December 1st to Jan 3rd. So it's taking time because I'm explaining it, but otherwise you can do it quickly. So from December to Jan, again 3 days. From Jan to February, from this Jan month, we'll be having again 3 days. Again, from February 1st to March 1st, since it is what it is said, it's 2020. So already now we are in Feb 2021. So it's not a leap year. So 28 days. So this will be 0. Again, from March to April, we're having 3 days. Again, from April to May, we'll be having 2 days. And from May to June, we'll be having 3 days. Now it is important. Now if you add all these days, 3 plus 3 plus 3 plus 3 plus 2, it will give to 14 days. Now if you add all these 14 days together, this will be divisible by 7. So exactly 2 weeks. So whenever it is divisible by 7, that completes the entire cycle of a week. So the correct answer is D, June. Correct answer is June. So you need to see the number of odd days. Now this number of odd days must add up to 7 so that we complete that cycle. Okay, so that's how you check and do it. Moving to the next question. On the 21st April 2020, Tuesday falls, what day of the week was 21st April 2019? Try this question. On 21st April 2020, Tuesday falls, what day of the week was 21st April 2019? 21st April 2019. Try this question out. So it's saying us on 21st April 2020, it's Tuesday. And again, it's asking us on 21st April 2019, we have solved a similar question. What will be the day? We have solved a similar question. Great, Jhalak and Rosalind, they're saying Sunday. Okay. So we'll just quickly go through. We have already done this question, similar question of this kind. So whenever it is asking that, you need to see, first consider that the difference is 1 year. You can easily note the difference is 1 year. Now what is important? Whether this year is a leap year or an ordinary year. Now you can see, whenever we are considering from 21st April 2019 to 21st April 2020, so in February 2020, it's a leap year. So if it is a leap year, then the February will be having 29 days. So if in a leap year, that words we know 366 days are there in a leap year. So if in a leap year 366 days are there, so we can have 52 weeks plus 2 days extra. We are having 2 days extra. So since we are counting in the reverse direction from 2020 to 2019, so this 2 days extra will minus from this Tuesday. This is important. Just one simple thing you have to do. Since we are counting from the reverse from 2020 to 2019, just you need to subtract 2 days. So if it is Tuesday, because 2019 will be coming first and then 2020 will be coming. So the sequence. So if it is 2020, it's a Tuesday, then just 2 days before it. So it will be Sunday. 2 days before it. So it will be Sunday. It will be Sunday. So the correct option is option A. 2 days before it, it will be Sunday. Okay. Moving to the next question. Now this is also a different kind of question that we generally see. What is the day of the week on 28th October 1996? What is the day of the week on 29th October 1996? You can try this. 28th October 1996. So in this type of questions, you will see various combinations where they will give you a particular date and they will be asking on which day it will exactly come. Okay, try solving this. Try solving this. So there is an approach to solve this question. Okay, so the trick to solve this question is to able to write the date that is given to us properly. Write this date that is given to us properly. So first to observe what we can do. Now this 1996 that is given to us, we can write like this. So we can start from 0 to 1900 plus 95, since we need to reach 1996 October 26. This is the typical method that we are seeing so that you don't confuse. So 0 to 1900 plus 95 plus January to September, then the month of 20 plus 28 October. This is how we can write this date. So starting from 0, we are calculating, we are trying to see starting from 0 to 1900 plus 95 years plus January to September, since just remove 1 month. So we need to consider October till October. So till consider till from January to September. Then the month will come October. Okay. And then the 20 days of October. So let's start this and approach systematically. That is more important. So in every case, you want to see the number of odd days. So that's how we can correlate the value that we'll be getting. We can correlate and find it. Okay. So what is the number of odd days in 0 to 1900? 0 to 1900. 0 to 1900. Try this out. What is the number of odd days in 0 to 1900? We know for 0 to 1600, the number of odd days is 0. The number of odd days is 0. So for each 100 years, we know that the number of odd days is 5. So from 1600 to 1700, it is plus 5. Then from 1700 to 1800, again it is plus 5. Then 1800 to 1900, the number of odd days will be again plus 5. So from 0 to 1900, the total number of days will be 15. Now if you divide it by 7, the remainder will be 1. So this extra 15 days can be again for 2 weeks plus 1 day extra. So in 0 to 1900, there will be 1 odd day. 0 to 1900, there will be 1 odd day. This is important. 1 odd day. I'll just change the color of the ink. 1 odd day. Okay. Now the next thing, 95 years. Again, in 95 years, you need to find the number of odd days. The same thing we will use. What we will use? We'll see the number of leap years and the number of ordinary years. The number of leap years, how do we find it? 95 divided by 4. That's how we find it out. 95 divided by 4. So you can see 8, 15, 3 to 23. So there will be 23 leap years. There will be 23 leap years. And again, the number of ordinary years will be 95 minus 23. So it is basically 72. Just 72. 72. 72. Now just if you see, if you just divide it by 7, so the number of it is important to see that in leap year we are having 2 days. For a particular leap year, we are having 2 odd days. So basically from 23 leap years in 95 years we'll be getting 46. And from 72 ordinary years we'll be getting 72. So since we are solving it, it might take hectic, but once you solve 1-2 questions, the concept and the logic behind is very simple. Okay. So 46 just divided by 7. If you divide it by 7, what you will get? 4 6 are 42. So 4 odd days. So basically in leap years, you are getting 4 odd days. Again, if you try this with ordinary years, you will be getting 2 odd days. You'll be getting 2 odd days. So for the leap year, we are getting 4 and here 2. So from this 96, we'll be getting 6 odd days. So I'll just rub this part from 96, from 95, sorry, from 95, we'll be getting 6 odd days, 4 plus 2, 6 odd days we'll be getting. 6 odd days we are getting from here. Again, from January to September, we just need to see from January to September. If you start counting from January to September, what you will get from January to September, the number of odd days, if you start counting, you'll get it to be 22. Since it's a leap year, you can just try it by yourself. For January, the number of days need to be 3, the odd days. For February, since it's a leap year, it is 1. So if you add all these days, it will come to be 22. So 22, if we divide it by 7, so we're getting 1 odd day. We are getting basically 1 odd day. We are getting basically 1 odd day. Since 22 days, we are odd days we are getting from January to September. Okay, from January to September, 1 odd day we are getting. Now, this 28 days of October. So this 28 days of October, if you divide it by 7, these are exactly divisible by 4. So the number of odd days is 0. Number of odd days is 0. Now you just add these numbers. 1 plus 6 plus 1 is 8. Is 8. Is 8. Now again, this number, if you divide it by 7, you'll be having 1 odd day. You'll be having 1 odd day. Now what this 1 odd day will correspond? We know for 0, it is Sunday. For 1, it is Monday. For 1, it is Monday. For 1, it is Monday. That's how we solve it. So the correct answer is Monday. So the correct answer is Monday. So I'll just again repeat this, what we have done. So the first task for you is to write the date in terms of this. 0 to 1900 plus 95. If 1996 is there, so 0 to 1900 you have already considered. 95 you have to consider again. And the 96th year, that you have to break it in January to September, and the last 28 days of October you need to consider. And again, you have to individually find the number of odd days. Now, if you add all this number of odd days, you will be getting equal to 1, and that will be equal to Monday. That will be equal to Monday. Okay, Sanchari, I'll explain it. I'll explain it again. So this thing, it is clear. So now I will explain how the number of days are 22 for January to September. Okay, just January to September, this thing will do. So January, February, March, April, May, June, July, August, September. Okay, so 31, I am just writing for the number of, if a month has 30 days, so there will be 2 odd days. For a month of 31 days, there will be 3 odd days. 3 odd days. And if it is 28 days, and if it is a February and 28 days, so that will be 0. And if it is 29, the leap year, then the number of odd days in the month of February will be 1. These things you keep in mind. So January is 31st days, so 3. February, February, you need to consider that this January to September, we are considering of 1996. This is important. This January to September that we are talking is from 1996. So this is a leap year. So in leap year, we'll be having 1 extra day for February because 29. Similarly, March is 31 days. So here we'll get 3. Similarly, April is 30 days. So 2. May is 31 days. So 3. June is 30 days. So 2. July is 31 days. So 3. August is again 31 days. So 3. And September is 30 days. So 2. Now, if you add all this, 1, 2, 3, 4, 5, 5, 15. Now, if you add all this, I'll just change the color. Just a second. Now, if you add all this, it will come to be 22. You can just add. You can just add. Okay. You can just add. You can also do the reverse way, Subra. You can also do the reverse way, but this is how the traditionally we can solve. In that way, you can get confused. So I taught this traditional method. Okay. So this is how we have completed the session where we have discussed some questions related to calendar. You can try this question and solve more and more so that you get more accomplished with this. Now, solving these questions need practice. Okay. Solving these questions need more and more practice. So practice more and more questions. The variety of questions are less. So you need to pick up the concepts and practice more. Okay. So we'll meet again with a very interesting topic from aptitude. Till then, take care. Thank you all. Thank you all for remaining in this session. And please subscribe to Telegram channel of Bytechnica. You'll be getting a lot of content there. You'll be getting notifications and all our regular updates there. So please join the Telegram group of Bytechnica and avail this learning that we are providing. And this will help you to make your career a wonderful one. Thank you all. Thank you. Thank you, everyone. Thank you, everyone.